Hello guys, welcome to iTest Learnings. Today we're going to look at the problem number 518, which is a coin change 2. There are two types of problems in the coin change. So this is the second one. Okay, so you're given a you're given a different denominations of coins, and you should see write a function to compute the number of combinations that make up that amount. You may assume that have infinite number of each of kind. So you are given a number of coins, like these are the denominations. The total sum amount is 5. So what you have to check, by using these coins, can you make sum up to this one or not, like how many ways you can make up to this sum. So let's say if you take one, right, you can pick this coin 5 times, which will make sum equals to 5. 1, that is one way, and 2 twos 1 1, that is another way, and 3 ones 1 2, that is another way, and only 5 that. So there are total 5 waves as it is shown here. So what you can do, if you think about the brute force approach, right, so you have to check all the combinations with 1, with 2, with 1, with 5, with 1 2, with 1 3, 1 5, with 1 2 5, all the combinations, check whether the sum is equals to 5 or not. So first we will implement that brute force algorithm. So we will check what we will do. First we will pick one to the solution, and without picking the one. So total we sum up both the result set and check whether the sum is equals to 5 or not. So let's do that. Let me write one recursive solution, which is DFS coins. Let's see the brute force algorithm first, and after that we will see how to do the same thing in the dynamic programming. Okay, coins and coins dot length. So this will return an integer. You can write an helper function here, and this is an array of coins, an array of coin. Let me put as set, and this is the length, and this is the total sum amount. So if what I'm doing, whatever I pick, right, then whatever the coin I'll pick, I'll remove that coin amount from that sum of amount. So when that means whenever it becomes 0, then I want to return. If n equals to 0, then return 1. If that is one condition, and if n is less than 0, which means let's say you pick amount 5 and you're subtracting 5, which is 0, and again if you subtract 0 minus 2, which is minus 2, so that condition I'm checking. If it is 0, then return 0, then don't calculate that as and the boundary condition, if m less than or equals to 0 and equal to 1, then also return 0, because we cannot go beyond the 0, right? That's the. So now return include sum up when it is include, when it is not include. When it is included means m minus, when it is not included m minus 1, which means the length will be reduced to 1 we are not including. And if you are not including, sum will not be changed, right? So let's say you are not including 1, sum will remain same. Now the other case, if you are including this one, right? So if you are including means the length will be same, and here from the sum, let's say if you're including 1 should be removed from the total amount 5. So the total amount yes of m minus 1, guys. So if you understand, right, when we are counting when it is included, which means let's say 1 is in. it is accepted. But when I submit, let's try submitting it. See, time limit exceeded. The reason being, this is a tree, right? Like when you are checking all possible scenarios, all possible cases. So in that case, what is happening, the time complexity is going to be the order of 2 power n, which is exponential. You are unnecessarily checking. What you are checking is, let's say you have a set, right? You are checking it for like 1 2 5. You check for all the cases of 1 without including 2 and 5, with including 2 and 5, all the cases. So let's look at the dynamic programming solution now. So let me explain. In the Excel I have already drawn something here. Okay, so the dynamic programming approach is here. Assume this is the amount, total amount 0 1 2 3 4 5, and these are the coins that it's given in the example 1 2 5, right? So when you include these two to sum up to 0, what will be the value? When you include 1, if the sum is 1, then what will be the value? If you include 1, if you want to sum up to 2, then what is the value? So that if we fill this table, then we can easily achieve without order of 2 power n, like with order of m into n we can easily achieve. The thing you understand here, why we are doing it here. If you look at that, the previous solution, it is a tree, right? So exponential tree. So there you are unnecessarily processing, though for one of the combination you processed already, but still again you are going to process in another scenario, in another combination. But here, if you have already processed something, that result you can store it here in the table and get that result back, and then populate it to calculate the another set of combination, right? So here, let's see here, I'll take I, and this is J, and these are the amount, these are the coins denominations, and these are the ones, the total amount. So now see, to get some 0, do you have to include, you don't have to dependent on 1, right? Do you choose or not? You don't have to dependent on 1 to sum up 0. No, let's fill all these are 1, because sum is already 0, whether you're choosing or not choosing, that doesn't matter at all. So this is 1. Now, so to this one, when you pick 1, and to make sum 1, to sum up to 1, what you have to do, you have to yeah, by looking at this, by picking up 1, you can easily tell that, okay, with 1 I can make up some 1, and 2 1 3 1 4 1, which means yes, you can make up with 1 coin, 1 2 coins you can make 2, 3 1 coins you can make 3. But the formula here, what you need to understand, the problem, the formula here, the way we discussed earlier, right? If it's picked, then we have to remove from the sum, right? The picked element should be removed. When it is not picked, if it is not picked, just take that previous solution. So right, so yeah, so if you look at here, when 1 is picked, then what you have to do, you have to remove from the sum that 1 minus 1, which is 0. So coins of 0 is what? This is 1. So like when you are processing the 1, when you want to pick the 1, this is the first element, you don't have anything else in your hand, so that's why 0 when it is not picked, 0, and when it is picked, pick this and remove it from the sum. 1 minus 1 0, so coins of 0 is what? 1. So 0 plus 1 is 1. This is the 1 here. So now you are picking 1, so remove it from the sum. 2 minus 1, it is 1. So coins of 1 is 1. 0 plus 1, that's again 1. It's the same for all, because we know it is 1, it is always 1. So coming to this one, right? So 2 0, it's already calculated. 1, right? So can you make sum up to 1 with coin picking up to? No, right? But how do you calculate it? So let's say you are picking 1. Before that you already have coin 1. You should also process that also, right? Yes, alone with 2 you cannot make sum 1, but other coin is already picked up. Other coin is already there in our solution set, which is 1. So which means we again have to follow the formula if it is picked and if it is not picked. If it is not picked, just simply take the previous value, this one, because we have already processed. If we are not picking, what else is left? 1 is left. When 1 is left, can you make sum up to 1? Yes, which says yes. Then you do that, right? 1. Just simple. Whenever the sum is less than the picked coin, then you take the previous value. Why we are taking the previous value? Because if you are picking or not picking, but you already processed the coin 1, so that's the reason. So here also the same. Now look at here. So now you are trying to pick up coin 2, right? When you are picking up coin 2, you have to remove it from this one. 2 minus 2 0, and coins of 0 is what? 1. And when, if you are not picking up, what is left? 1 left. And when you have only one coin, can you make up sum 2? Yes. So what is the value? The previous value, that is 1, which is equals to 2. The same. 2, 3 minus 2, 1, coins of 1, 1, 1 plus the previous value 1, 2. 4 minus 2, 2, coins of 2, 2. 2 plus the previous value 3, right? Now 5 minus 2, 3, right? Coins of 3 value 2. 2 plus previous value 1, 3, right? So now 5 minus 1 minus 5. Here, since the sum is lesser than this one, you don't have to pick this one. If you don't pick this one, what is left? Till here, whatever you picked up, that you have to put here, 1. Now again, the sum is lesser than the coin, then you have to pick whatever you picked so far here, like coins 1 and 2 together to make up sum 2 is what? 2. Then put that here. And here 5 is also a less than, is greater than 3, simply pick up the previous value. And 5 is again greater than the 4, simply pick up the last value. Now 5 is not greater than, it is equal. So if you pick this one, you have to deduct from the sum 5 minus 5, 0, right? The coins of 0 is what? Which means what? When you are subtracting 5 minus 5, which will become 0, to make 0 sum, what is the value? It is 1. So 1 plus the previous value, 3, 4. So when we write that formula, you will understand. If you don't understand, that's okay. When we write that formula, then you will understand easily. So let's write that here. Right. Okay, so we need one result set. We call it as DP, 2-dimensional array, which is of m and n. The total, if you look at here, this is n, this is m. Why this is n? Because if we have the amount is 15, we will have 15 columns here, the total number of coins. So int dp equals to new coins dot length, and here the amount. We will take one extra because we will start from 2 for loops, right? So this is for one for loop and this is for another for loop. So let's int I equal to 0, I less than or equal to constant length I plus plus. Now another for loop, int j equal to 0, j less than or equal to amount. This time it's amount I plus plus, sorry, j plus plus, right? So what we have to do, as we discussed here, if whenever the j equals to 0, fill with ones. If j equals to 0, j equals to 0, dp of I j equals to 1. Else what we have to do, else what we have to do, if the condition what we've discussed, if you look at here, let's say 5, whenever the sum is greater than, sorry, the coin value is greater than this one, then simply pick the previous one. If j, right, in this case j is the amount here, if j is greater than, the, sorry, if coins of j is greater than the j, right, like this, if 5 is greater than 0, then simply pick the previous value, which is of coins of I minus 1 comma j. So let's program dp of I j is equal to coins of I minus 1, the previous value, right, j. Here we need to actually what we have to do is, this is fine, but one condition we need to check, whenever if it is, if I minus 1 less than 0, right, and else is what, this case, let's say 2 is greater than this one is not. So if it is not greater than, less than, then what we have to do, pick, you are picking, subtract it from the sum value 2 minus 2 0, and what is the already processed value of this row of 0 1, right? So let's take the same thing, control C. What we have to do, this value plus picked value, right? Pick when it is picked, when it is not picked. When it is picked, you have to minus it from this value and store it, and when it is not picked, then you take the previous value. The previous value is the same, I minus j plus coins of, here I will be the same one, and j minus, you have to get the coins of sum minus this is actually dp coins of I, right? So this is again dp, this is the result dp dp. So if it equals, if I less than or equal to 0, that's it. Now return dp of coins dot coins length amount. So yeah, I just made it this one. If you look at here, if the coin the value, the coin value is greater than the amount, then we are simply taking the previous value, this value we are taking, right? If it is greater than, we are simply taking. Else what we are doing, if it is not greater than, then previous value, which means it is not picked, and when it is picked, you subtract from the sum amount, and whatever it is processed before, or pick that value, right? So this is the one. Let's try running. Yes, it's working. Let me show you like how I put it here, controls, how that is being shown here. Yeah, so this is how it is being calculated exactly. If you look at my this one, exactly this is the table which is calculated. You understand when it is picked, when it is not picked. If it is picked, and then if it is picked, then remove that picked coin from the sum of amount. So the value you must have already processed before and pick that value. That's it. Okay, so on time complexity for this one, order of